So if we are to consider our previous exercise, it was to sketch, that is to sketch a parabola or a quadratic function. In this case, we have a different situation at all, which is on how to determine or to find the equation this time of that quadratic function. Okay. Remember previously you were given y is equal to x squared minus 5x minus 6. Then you're asked to sketch this function. Okay. You know, it's a quadratic function. Already you can see it from the equation. Now they want you to have this equation given a function. How can we have this? All right. So there are so many ways that we can actually have in determining or finding the equation. So I'm just going to explain some of these. Then we go through the questions so that we can see how can we apply this information. So the first part, it's a condition where you'll be given the x-intercept or the x-intercept and 1 point. Take note, you are given the x-intercepts and 1 point on the graph. So this is a condition of this nature. When you have got a function, all right, so I'm just going to have it this way. This is your Cartesian plan like this. So on the function, you'll be given the intercepts, all right? So you can just have something like this, or maybe you are given something like this. The graph can be drawn. Then they want you to determine the equation, mostly if you check the exam questions. So they can just give you a sketch already drawn. And on that sketch, you'll be given the x-intercepts, all right? Let's just call our x-intercepts x1 and x2 to represent our x-intercepts. And you are given 1 point on this graph, any point, any. So the point can be here, it can be here, it can be anywhere, all right? Not specifically to say it's a turning point, it's just any point. It's just any point which is found on the graph. Any point. Any point. So we're just going to put the turning point aside for now, but let it be any point that can be found on the graph. In this situation or in this manner, or when you have got this condition, you can have the equation of the quadratic function by using this formula. Y is equal to a into x. All right, so you're going to have x minus x1 into x minus x2, where x1 and x2 are the what? The x-intercepts. So take note, we are going to substitute the values x1 and x2. We substitute them in place of x1 and x2 there. All right, that is to substitute the values of the x-intercepts. Substitute the given point, which is not the x-intercept. So in substituting, remember you substitute the x-intercepts. You have to substitute in order for you to find or to solve for any point that is on the function, but not x-intercepts. That is for you to solve for what? For a. Then after determining this, you substitute again so that you can rewrite the equation of the function in this format. Remember our quadratic function, y is equal to ax squared plus bx plus c. We talked about this. So when you are given x-intercepts, like I said, I'm going to explain this with our questions. Another part is you might be given the turning point and 1 point. This time, it's a special condition on its own. It's a special condition on its own. You have got a given function. Let's say just any way that you can have your function. All right. And on this function that we are having or that we are given, we have the turning point. All right. The turning point is given. All right. So let's say our turning point is called P and Q like this. Let's say our turning point is PQ. And you have any point which is on the function. It can be here, it can be here, it can be here, it can be anywhere as long it is found on the function. So we've got any point. When you are given this condition and your turning point is given as PQ, you can have the equation of this function by using the formula, right? So in this case, this one, it's when your turning point, when you're using this, when there's a plus, it means your turning point was minus PQ, like this, all right? So if you are using PQ, remember I explained that this one can be given also as A into X, all right? So you're going to have X minus P squared plus a Q. This is a condition when your turning point is positive P. So this negative changes to positive. So it will be P, Q like this. This will be your turning point. Right? So any format, guys, as long you understand what is important is this is just a format to say your answer can be written this way, or you can use your formula in this manner. So even in the presentation of your final answer, you can present it this way. So there can be a positive, there can be a negative. But what is important is that the value that is here, let's say your turning point is 3, 4. The value of X changes when you are substituting. It becomes a negative. If it is negative 3, 4, the value of X changes when you substitute, it will be a positive. That is the only condition that matters there. All right. I hope you understand this concept. So this is the format that you're going to use whenever there's a turning point. Remember, I explained this format on its own on sketching the functions of this format when you're given this format. So that part, it must make sense of the turning point. All right. So that is the condition. Once you have this equation, you are going to substitute the coordinates of the turning point, which is PQ. All right. So if you're given PQ, you substitute them. Take note when substituting P changes to a negative, Q remains as it is. You solve for A by substituting the given point, that is any point which is on the function. You substitute that so that you'll be able to solve for A. After solving for A, write the equation in the form, so you can leave it in that form that you're already having, or you can expand it and write it in this way, depending on the instruction in the question. So there you have to follow the instruction of the question. It is different from this one. Also here, they can also specify the instruction. But in this case, you cannot leave your answer. Let's say you've got y is equal to, you know that the value of A, maybe it's 2, and this is x minus 3. Maybe it's x plus 4 like this. You cannot write your answer like this. In this case, you are forced to expand and write it in this manner. But after even writing it in that manner, they will even ask you maybe to express it in the form. It differs. Maybe they ask you to write your answer in the form of A into X minus P squared plus Q. They asked you to write in this format. Then you have to follow that instruction. All right? But if not given an instruction, in this case of this one, write it in the form of a quadratic function that you are used to. Then for this one, you must follow the instruction. But otherwise, if you are not given the instruction, it will be best for you to just maintain the way that it was before. Guys, expanding brackets, it will be a waste of time if we are not asked to express it in this manner. Okay, so that is for the quadratic function when you're given the turning point and 1 point. So you're going to also consider questions, like I said, to see how to answer the questions. Then sometimes you might be given the coordinates of 3 points on the parabola. There are 3 points, right? So if you are given 3 points, you are going to consider this formula. So let's say you're just given randomly 3 points. You can use the formula, okay? One of the given points is y-intercept. Therefore, C is given substitute. It will be depending with the condition that it will be having the y-intercept. So if you're having y-intercept, then you can take that to say y-intercept. You can just substitute. Remember, C represents the y-intercept. So this condition, it will be best to be explained, let's say, working with the question. All right? That would be best for us to talk about this one. All right, let us consider typical questions, guys, using or applying this information. We've got just few questions that we're going to consider. On the first part, you are given to determine the equations of each of the following parabola. So we have got the first one. This is our first parabola that we are given. As we can see, according to the shape, right? That's our parabola, guys, all right? We cannot say this one is a straight line, no. Okay, remember your functions, guys, okay? The shape. So what is it that we are given? All right, this is 0, 2. 0, 2, it's a point which lies in the y-axis. When x is 0, y is 2. So the indication, guys, there it would be like it's just any point which is here, 0, 2. All right, remember, when x is 0, you are in the what? You are in the y-axis. All right, so that's the point. 0, 2 is directly, that is the point for the y-intercept, all right? So that you do not have a confusion. The point is here. Then the -1. So guys, these books, I don't know when they are. It's here. This is the -1 and this is the 4 here. So that is our 4 and that is our -1, the x-intercepts. So that is our condition of our question in this case. So we have the x-intercepts. We are given x-intercepts and any point. That is what we have. Okay, this is what we have. We have got the x-intercepts and any point. So meaning to say, when given the x-intercepts and any point, this will be the best way to answer your question, to have in this way. Like I explained, we're going to have our formula, then substitute the values that we're given to solve. All right, so this is it. From what we had, we are going to have this as y is equal to a into x minus x1 into x minus x2, where x1 and x2 are these ones, they are to be substituted with the x-intercepts. So we can just call this x1 and this one x2, the x-intercepts. So that means y is equal to a into what? X minus x1. Take note, this is -1. So it was going to be x minus -1 like this. So what are we going to have, guys? Minus, minus, that's a plus. So that's x plus 1 into x minus 4. So this one is just direct. There is no adjustment to be made. So that's x minus 4 like this. All right, this is where you are. You substituted those x-intercepts, x1 and x2, into the formula. But as we can see, there's still an unknown value, which is a, this one. We do not know that one. So how are we going to determine or have the value of a? By substituting any point now, which is given on the graph. There is a point which we are given as 0, 2. So from the point 0, 2, what is it that we are having? Remember, a point is made up of x and y. So you have the x value and the y value at the same time. So that is an advantage because we can simply substitute to say the y is what? According to the point, y is 2. So that means 2 is equal to a into x. All right, the x value is what? Is 0. So meaning say in place of x, we are going to substitute a 0 there. So that's 0 plus 1, which is 1, guys. All right, this one you can just write it direct. 0 plus 1, remember that's 1. This is 0 minus 4, which is what? Which is minus 4. So we are going to have a -4 like this. All right. Or you can just substitute, like I said, direct. All right. Some of us guys, in terms of this calculation, you want to be direct. 0 plus 1, we're going to substitute another one, 0 minus 4. That is what it means. The calculator can simplify this. Do not worry about that. Calculator knows this. So you can use your calculator, 0 plus 1 into 0 minus 4. That was going to give us a -4. So it's A times -4, which is same as -4A. All right. Remember your multiplication. So to find A, simply divide by a -4 both sides. That was our A was going to give us -1/2 by dividing this one properly. We're going to have -1/2. So that is our A. The one that was missing here, now we have it. So therefore, what does it mean? It means Y is equal to, in place of A, we substitute the A that we got, which is -1/2, into everything as it was. All right? So you're going to substitute everything there as it was. Sorry for that. Everything. So that's into what? Okay, as it was, we're going to open a bracket, x plus 1 into x minus 4. All right, that's x minus 4, like this. So this is where you are. Like I explained before, that whenever you're working with this format, you have to expand the brackets, because as we can see, guys, we can see it's a quadratic function, yes, because we've got 2 brackets. But in the presentations that we had, it is either we write it in the form of ax squared plus bx plus what plus c, or you write it in the form of a into x minus p squared plus q, like that. Not just brackets like that. So in this case, you'll be forced to expand the brackets so that you can have your equation of this function in this format. All right. So let us expand our brackets. So meaning to say y is equal to -1/2 into what? So you're going to expand, remember, by the FOIL method. So let us just have the first bracket expanding second one. Everything in the first bracket has to expand the second bracket. So that's x times x, which is x squared, x times -4. That's -4x. Then we move on to this +1. That's +1 times x, which is +x, +1 and -4. That's a -4. So meaning to say y is equal to, we can collect the like terms before we expand the bracket by this -half. Let us just collect like terms inside the bracket. We've got x and x here. So that is 1. So we are going to have -4 plus 1. All right, that's -3x. -4 plus 1, that's -3x minus 4, like this. This is what you're going to have. Then you can expand by -half. Each and every term has to be multiplied by -1/2. That's -1/2 times x squared, which is -1/2 x squared. -1/2 times this -3 minus, that's a positive. So you're going to have +3/2x -1/2 and -4. It was going to give us a positive, which is +2. So we have it in the normal way that we are used to. Y is equal to ax squared plus bx plus c. So you see the condition there is important. What are you given? We have X-intercepts. So the format, you'll be limited to this way. Substitute the X-intercepts and take note there is already negatives on the formula. So if a value has got a negative, it is going to change. Negative will be a positive. So these questions will be, you're not going to be just given a simple sketch like this under exam. There will be other functions there, but they'll ask you to find or to determine the equation. So you have to figure out the intercepts and any point that you'll be given from there. So it's something that you have to figure out. Remember, when it is exam, they will be testing you a lot of things. On number 2, you are given, again, we are still on determining or finding equation. So in this case, we were given the turning point. So this is directly the point that we are given there, which is our turning point. And we have got the point 2 minus 4 here, which is any point. So we said whenever you are given this condition, it will be best that you apply this way. All right, remember, for here we explained when given a turning point, this will be the best way to answer using this formula. Like I said, you can use this one, the negative, or you can use this one, the positive. What is important is when substituting the turning point, it changes the sign, positive to a negative. If it is a negative, it changes to a positive. All right. So in this case, you are not even told like how to express your answer in which format. So you can even leave in the format that you are having as a turning point concept. All right. So let us quickly have our question. So remember, y is equal to. All right. Let's see. So remember that y is equal to a into x minus p squared plus q, meaning to say y is equal to a into, like I said, from this condition, PQ will be our turning point. So what is our turning point? 1, 2. Our turning point is given as 1, 2. So take note, as it was P, it is changing to minus P. So if it is 1, it is going to change to a minus 1. So that's x minus 1 squared. The Q remains as it is. The point there, Q, is Q. So the 2 there on the Y value, or which represents our Q, it must remain as it is, as a positive 2. Take note. So the X has to change. If it was a negative, it was going to change to a positive. All right. So this is where you are. As you can see, we still have an unknown, which is A, that has to be determined, to be calculated. So how are you going to have the value of A? That is by substituting any point that you'll be given. So from the point 2 minus 4, just like in our previous case, I explained that it represents the X and the Y value. So thus you are given the X value and the Y value at the same time. The Y value in place of the Y, so that is minus 4, is equal to A into X. What is our X in place of X? So our X is 2, so that will be 2 minus 1 squared plus a 2. All right, this is where we are. So that means we are going to have minus 4 is equal to 2 minus 1 squared. You can even use your calculator. That was going to give you 1. So 1 times A is like this, A times 1, or 1 times A, that is A plus 2. All right, so we simplified this and got a 1. Then 1 times A, that's our A. So to find the value of A, we're going to take the 2 to the other side of the equation. So this is going to give us a negative. So that's A is equal to what? Minus 4 minus 2, which is minus 6. So that is our A. So A is equivalent to what? A negative 6. So meaning to say, in our presentation with this value of A, we can have our equation as y is equal to, in place of A, we substitute there, minus 6 into what? All right. So here we are. So we're going to substitute here on this part. All right. Going to substitute here on this one. Remember, this is where we had the A that was missing. So that is where we are going to substitute the A that we calculated, which is the minus 6. So everything remains as it is, which is x minus 1 squared plus 2. It remains as it is. So if you are given to express your answer in this form, you're going to leave it that way. All right? Or let's say they asked you to express your answer in the form of y is equal to mx plus c. All right? Oh, sorry, in the form of y is equal to ax squared plus bx plus c. Let's say you asked to express it in this way. You have to expand the y that we had, which is minus 6, into x minus 1 squared plus 2. All right? So meaning to say y is equal to minus 6 into what? Remember, your identity is there. So that's x squared. All right, we are going to have minus 2ab, which is minus 2 times our a, which is x, our b, which is 1. So it is going to be minus 2x. All right, remember the last term squared, which is 1 squared. 1 squared is 1 plus a 2. So guys, how to expand this? It's in your hands. You can expand any way that you understand. Still, you're going to have the same answer. But in that case, I simply used, remember, x, or let's just use a and b. A minus b squared is equal to a squared minus 2ab plus b squared. All right, so you can even use this concept where we've got our a and our b separated just like this. This is your a and 1 is your b. All right, so that is what you're going to have after expanding in any way that you understand. Then from there, we can expand this bracket by distributing by what? The negative 6, which is outside of this bracket. Each and every term has to be multiplied by that negative 6. Each and every term inside of the bracket. So what are we going to have at the end? Negative 6 times x squared. That's negative 6x squared. Negative, negative. That's a positive. 12x. Negative 6 times 2. Negative 6 times 1. That's negative 6 plus this 2. That is already given. So we are going to collect the like terms. So y is equal to minus 6x squared plus 12x minus 6 and positive 2. That was going to give us a minus 4. So that's it. We have got the equation. And in this case, never be tempted to divide this equation to reduce, this equation. It's an equation which represents a function, not an equation that you are solving like minus 6x squared plus 12x minus 4 is equal to 0. When it is like this, you can reduce that equation. But this one, it's an equation of a function. It cannot be reduced to say we can reduce by minus 2 throughout. No, that one is not possible. So you have to write your answer in simplest form as it is. So questions can be given in different ways. You can have your questions in different ways as long you are given the format, like the presentation at the end, like how to express your answers. Are you given in this way, or are you given in this way, which is the turning point concept? All right, so this one is of the turning point concept. It depends with the question. All right, so we're going to consider another part. Let's see. We have got this one. If we are to consider this question, we can see it is similar to the first question because there we are given the x-intercepts, all right? The minus 3 that we are seeing there, it is simply our x-intercept here, all right? That's our x-intercept, and the one that we are seeing, these are the x-intercepts, and there is any point that we are given, all right? Remember I said whenever you've got this condition, we can simply use this way: y is equal to a into x minus x1 into x minus x2, where x1 and x2 are the x-intercepts. So you can just call this x1 and this one x2. So by substituting into this format that we are given, this is the basic part that you need to actually understand, when dealing with your functions. Yeah, what are you working with? This is not how you're going to answer when you're finding the equation of a linear function, when finding the equation of a hyperbola. It is of the format When you're dealing with a cubic function, it is different. So you need to know each and every function, its basics. All right. So let us quickly have this one. So that is y is equal to, remember your intercepts x1 and x2. This is -3. So if you put a -3, it was going to change. Negative, negative. That's a positive. So that's x plus 3 into x minus 1. All right. If you put a 1 here, it's just going to remain as a negative. As you can see, we do not have the value of a. So using any point, last time we had, or we were given it as the y-intercept. So you just substitute it. This time it's another point, not the y-intercept. It's any point which is on the function. The case does not affect our calculations, guys. We still have the same thing. From any point, you substitute the value of x and the value of y. What is our x value? What is the y value? So in this case, y is -6. So in place of y, we are going to put -6 is equal to a into x. In place of x, every part where you see x, you substitute -2. So that's -2 plus 3. Place of x, -2 minus 1. So that is -6 is equal. You can even divide by this bracket, as you can see, or you can simplify the bracket and see what is inside, like these numbers when simplified, but that was going to give us a -3. If you simplify the whole of this part on your calculator, that was going to give you -3. That means you are multiplying a times -3. That's -3a. All right. The whole of this part was going to give you a -3. So divide by -3 both sides to obtain the value of a. That is, our a was going to be 2. All right. Just like that. So having this value of a, we are going to substitute. Remember, in this case, we had this part here where we substituted, but a was missing. We're limited here. We're limited because we're not having a. So now that we've got our a, therefore, we're going to substitute the a, and this is what we're going to have. So therefore, y is equal to, in place of a, we are going to substitute the 2. So that's 2 into x plus 3 into x minus 1. Like I said, we do not have a format like this in our quadratic functions. The formats, we know them. So we are forced to expand the brackets so that we've got the exact format that we are used to. Using your FOIL method, let us quickly expand this. That's y is equal to 2 into x and x, which is x squared, x and minus 1. That's minus x. All right, so we move on to 3. So that's 3 and x, which is 3x. 3 and minus 1, which is -3. Then we're going to collect the like terms. That is going to be x squared minus 1 x plus 3x. This is -1 plus 3, which is 2x. So that was going to be 2x minus 3. Then we distribute everything inside of this bracket by what? By the 2, which is outside of the bracket. So this whole part of the bracket has to be expanded by the 2, which is outside of the bracket, which is 2 times x squared. That's 2x squared. 2 times 2x, that is going to give us 4x. 2 times -3, that's a -6. And like I said, never tempted this condition to divide. It's an equation, yes, of a function, not an equation that you're supposed to solve like you're solving for x, where you can reduce by dividing left-hand side, right-hand side, what is common. No, in this case, just leave your answer as it is. So these are the typical questions that you are going to be working with as you are working with your functions. The quadratic function or the parabola, you just need to work out as much questions as you can, try to figure out how questions are being given, like in terms of the information. Like I said, when it is exam, they're going to combine everything that you had in terms of your functions. So you're not going to have just a simple sketch like this. This sketch will be combined with other functions. Maybe there's a hyperbola there. Maybe there's an exponential function. But the part of the parabola will be having some values, and you'll be asked to find the equation in any format that you be given. Answer the question. Exam, it's all about answering the questions. Exercise, they are just testing you. Just know the basics of the topic. So do revise as many question papers as you can.